Okay, one more member of SAR, one more member of Alveolata are the dinoflagellates. The Dinoflagellata. And dino, you might think, oh, like a dinosaur? No. As it turns out, dinosaurs means thunder lizard. Dinoflagellata comes to us from a different Greek word root that means whirling or spinning. And you'll see why once we draw our dinoflagellate. These are single-celled organisms, some of which are photosynthetic, they're algal, some of which are parasitic and can cause important diseases, such as the red tide that we find in oysters. That's caused by a dinoflagellate that produces a toxin that if you eat the shellfish that are tainted with the red tide organism, you can get very sick. All right, so essentially we're going to draw this shape. Okay. This is our single-celled organism, our dinoflagellate. It is going to have two flagella. And unlike the flagella that we saw in our brown alga, and our phaeophyte, our bull kelp, these two flagella are going to be pretty much the same in structure. We don't have tinsel and whiplash. We just have two flagella. But their position is also not the same as it was, both being kind of lateral on our brown algae. Okay, so we've got two flagella. We've got a transverse flagellum, and we've got a longitudinal flagellum. Longitudinal flagellum. And both of these flagella are beating and allowing the animal to move. So because you've got this transverse flagellum that's flapping around, it's going to, in effect, it's going to spin the organism as it swims. The longitudinal flagellum is going to push it in this direction. So that they're going to, when you look at them under the microscope, you'll see them kind of swimming along. And as they're swimming along, they're kind of whirling around as well. So that's how we get the name dinoflagellates. So there's a bit more to the anatomy of them, but only one more thing I really want to point out here, which is that many dinoflagellates have cellulose plates that form a structure called a theca. So the thecal plates are often very diagnostic as to what particular genus or family of dinoflagellate you're looking at. Some dinoflagellates do not have thecal plates. They don't have a theca. But in our case, sorry, it's supposed to be representing spinning around. It's an arrow. It's another arrow. But the different patterns to the thecal plates very diagnostic. And that's basically all I want to show you on this particular dinoflagellate. Enough to remember that they spin around and that they have these cellulosic thecal plates. So I've often said that the protists, essentially they come with 3 different types of suits of armor. They can either be siliceous, like we see in diatoms and we see in radiolarians. They can be calcareous, like we see in foraminiferans, and there's a few other protists that have calcareous or calcium carbonate suits of armor. And then here in the dinoflagellates, we've got a 3rd type of suit of armor, which are these cellulose plates.